All right, hello everyone. We are getting into the second day of 6.4, which is actually the last thing that we have here for chapter 6. Um, like I said in the last video, we are going to have a quick little review at the first part of next week. I'll make sure to post that practice test probably on Friday on Schoology. So you have plenty of time to kind of work through those problems. We can review in class, and then either Wednesday or Thursday is going to be that chapter 6 test, depending on if you're group A or group B, obviously. Um, it's really going to be the last test, the last big grade that goes in for the trimester. I know a lot of us are working really hard to pull up our grade, which is awesome. A good grade on this chapter 6 test is probably one of the best things you can do to raise up that grade. So everyone just keep working hard. Make sure you've got good notes. We can always use our notes and everything on our test, and we should be in good shape. All right, so today we're going to go into compound interest. Again, this is why I really like this section, is because we start to really connect things to actual real life situations. It doesn't just seem like straight algebra. Compound interest is really interesting because we start talking about maybe investing or a retirement account, maybe college savings. There's certain type of accounts where when you earn interest, that interest gets lumped in with your other money, and then the next time it calculates your interest, it's also counting that interest. So if I have, I'm saving for retirement, and I have, every paycheck, so much money goes into that account. Well, if it's compounding monthly, every month it's going to calculate some interest, and it's going to add, I don't know, an extra $10 into my account. And then the next month, it's going to calculate interest, including that $10 that it added the previous month. So you're earning interest on your interest on your interest. Okay, the reason we do so many of these type of problems is we want you guys to see how much money that can turn into and how beneficial that can be. Okay, so compound interest is similar to the growth and decay formulas that we learned. It's really always going to be plus. Sometimes I see there will be some that where it's calculating maybe a loan where it's subtracting, but I'm not going to give you any problems like that. You really are just going to do compound interest where it's adding on the interest to your account. Okay, so we've got a couple different things that we need to know. We've got our principal, which is not like the principal like Mr. Gibbs. It's the initial amount of money that you're getting put in. Okay, so a lot of times it'll say, okay, you put $1,000 into this account, or $50,000, or however much money you're just putting in the account. That's your principal. You've got your annual interest rate. Okay, we say that's in decimal form, just like before when we had something like 5% or something, we wouldn't say 5. You change it to 0.05. Same thing here. We want the decimal form. Right? Our time. Okay, how many years that we're going for. Okay. And then N, this is kind of the new aspect of this. N is the number of times it's compounded per year. Okay. So N means, like I was talking about before, my example where it's compounding every month, okay, that would be 12 times a year. If it was compounded every quarter, sometimes people will say quarter, it's every 3 months, so that's 4 times a year. If it's compounded annually, that means it's compounded once per year. So it's how many times per year is this happening? And actually on your homework today, I have kind of a little like cheat sheet of when it says semi-annually, it's this many times, or quarterly, or weekly, it's this many times. Okay, so make sure you kind of understand what those different things mean. So we see n in two places here in this formula. We see right here, we divide our rate by it, and we also multiply our time by that. Okay, so let's go ahead and put all that stuff together. Let's do one of these examples over here. It says, how much will you have after 2.5 years, if I invest $500 at 8% compounded quarterly. Okay, so let's think about what all these things are. 500, that is my principal. That's my starting amount. 8% is going to be my rate, and I know I need to change it from 8% to, okay, move that decimal point over to 0.08 as my decimal. And then quarterly, that is going to be, okay, how many times that's compounded. So that's my N, and I know that quarterly means that's every quarter, so every 3 months, so that's 4 times a year. Makes sense, right? Quarterly is 4. Now let's throw that all into my formula. I've got, okay, Y, that's my, final amount. That's what I want. Okay, so I get P, so final amount, so that's my starting value, 500. I have 1 plus R over N. So that 0.08. We have lots of fun numbers with this. Okay, 8 over N, which is 4. And then my exponent, I have N times T. So N is 4. Oh, and I didn't come up with my T. 2.5 years. All sorts of fun numbers. So my T is going to be 2.5. Okay, so 4 times 2.5. All right, so I've got a ton of stuff I can do to kind of simplify this and give myself some nicer numbers here. Okay, first off, let's take that 0.08 divided by 4. That's pretty ugly. That's pretty gnarly. Let's simplify that a little bit. Okay, 0.08 divided by 4. Plug that into my calculator, I get 0.02. Okay, 4 times 2.5. I get 10. I could do that in my head, but I just want to make sure I wasn't making a silly mistake. Okay, so I know that that's to the 10th power. Okay, I simplified that to 1 plus 0.02. So now this is looking an awful lot like a growth, or I would say decay, but we're adding. So it looks an awful lot like an exponential growth problem. Okay, let's keep simplifying stuff here. Okay, 1 plus 0.02 is the same thing as 1.02. Okay, I multiplied that 2.5 and the 4 to get 10. All right. Again, I'm not going to multiply 1.02 times 500. I know I need to take that 1.02 to the 10th power. All right, so I get this long, crazy decimal. It's like 1.218, and it goes on and on. I'm going to keep it in my calculator. So I'm not going to put 1.218. I'm going to leave that number in my calculator and just hit multiplied by 500. That's how you're going to get the best, closest answer. If you just leave it as a 1.218 or whatever it is and multiply that by 500, it kind of rounds your answer a little bit. You might get something a little bit off. Okay, so I get 609. I get 0.49721. So I never really want to go more than 2 decimal places if it's money. Hey, it doesn't make sense to go farther than just 609 and then 50 cents. Hey, it was 49 and then 7, so that 7 I rounded it up. Okay, so final answer here, I'm going to have $609.50. Hey, that's pretty amazing, right? If you had $500 and you were able to find something that compounded your interest like that after 2.5 years, okay, you would have made $100, more than $100 doing nothing. Okay, that's pretty awesome. So if you have money from a job, if you have any type of income coming in, look into getting something like a Roth IRA, these different things that you can do where it can compound your money, because you guys have nothing but time before you need that money, right? And you can really, really increase some of the problems that we're going to see. You can get thousands and thousands of dollars over years and years just by leaving your money in these types of accounts. Okay, it's pretty awesome. We have a 6.4 day 2 assignment with all these different types of problems. You can go ahead and get started with that, and that is going to be the last homework assignment we have before that Chapter 6 test. Okay, so make sure you get that done, and I'll see you later.